Learned about inverses before. If you've taken Math 12 before, if you're taking it concurrently, I guess you can just learn it here, and then you'll know it when it comes up in Math 12. The inverse of a function, you actually know the concept already. The word inverse, if you use the word inverse in everyday language, it has something to do with reverse, almost like, or turning something around. Okay, in mathematics, the inverse of a function is the opposite function. Right? Adding to, the opposite of that is subtracting to. So if you have a rule that says take a value, add 2, and you take a number, 7, you get a 9, right? So on that function, this function right here, the point 79 is on that function. If you take the inverse of that function, which is the opposite, subtracting 2, if you put a 9 in there, you get a 7 back, right? It undoes what the other function does. First one turned a 7 into a 9. This one turns a 9 back into a 7. So the reverse point is on there. 9, 7 is on that one. If you have something that says a, b is on a function, you know the point b, a is on the inverse function. For a graph, you learn that that is like a reflection across this line right here. If you have a point that is 2, 1, that point gets reflected to 1, 2 as its inverse. The coordinates are just reversed. If you look at two functions that are inverses, they have that symmetry across that line. All right? The good one to look at is this first one here, x cubed. X cubed, if you remember what it looks like, if you've ever seen it before, it's something like this, right? I guess a person could actually... So if we graph y equals x cubed, power of 3. Okay, there's y equals x cubed. What would the inverse of that be? What's the opposite operation to cubing something? Yeah, cube rooting or third rooting. On here, you need to do, because I don't know if there's a cube root function. What's the other way of writing cube root? Yeah, to the power of 1/3. You can do to the power of 1/3. Like on your calculator as well, you can do that. It's the same thing. But that's the inverse of that function. Any point that you have, if this point is, that point is common to both because it's 1, 1. But if you have a point here, that's going to correspond to this point here, except I missed a little bit. Now let's try moving that, hopefully. Approximately right? I'm pretty close. Actually, I'm totally off there, aren't I? Aha, because I can't count. That's why. That's pretty close. The coordinates are reversed just other than the slight 2 decimal place problem. But those points are like that. If you put a line down the middle here, y equals x, that diagonal line, it's got a reflective symmetry across that. If you could turn the screen up, you'd see it's got that symmetry across that line. All right? If you're trying to determine the inverse from a list of points, you can do exactly what we just did there. Just reverse the points. If you're trying to determine the inverse from a graph, you can reflect it across that line. If you're trying to determine the inverse from an equation, sometimes you can just see it if you just happen to know what the inverse operation is. Right? Adding 2, the inverse is subtracting 2. If we write a function that says y equals x times 3 minus 5, think about undoing those operations. This was multiply by 3 and then subtract 5, right? To undo those things, you have to undo them in the reverse order. How do I undo those things? If somebody says, I'm taking a number like 7, I am multiplying by 3, and then I'm subtracting 5. How do I undo those things to get back? Because this would give me, what does it give me here? 16 or something? How do I go backwards to get back? Yeah, you got to do this one first. It was the last one done in this function, but when you're working backwards, just like when you're solving that as an equation, the inverse of that is going to be take the value, add 5, and then divide by 3. This is the inverse of this. You got to do the inverse operations in the reverse order. Now that might not be good. You might not be satisfied with just having to think about that. The mindless way to do it without thinking is to, if you have done it before, is if you want to take this function, y equals 3x minus 5, you can just switch you can do exactly what you just did with the points. With the points, you just reverse those two, right? So you can switch those and say, I'm going to put this where this is, and I'm going to put this where this is. You switch the x and the y. You can do that on your paper, right? With your lasso tool. You switch them like that, and then that's the inverse. That's the inverse, but it's not written in the form we like. Usually we like it to say y equals. You can do that. That's not that hard, right? Move the 5 over. X plus 5 equals 3y. And then divide by 3. Y equals x plus 5 divided by 3. That's the inverse. If you want to use some notation, people like to use notation. If that first function, if this was called f of x, if f of x was 3x minus 5, you could call this other one f inverse of x. It's really unfortunate that somebody chose this as the notation because it gets people confused. The notation's fine if you know what it means. Why is this bad notation or bad choice, whoever decided this, why is that a bad choice for notation used for the inverse of a function? Sorry, what? One person at a time. Yeah, it looks like to the power of -1, which is the same as what? Reciprocal, right? Yeah. I mean, it's not 1 over the function. It's not 1 over f of x. You did this in grade 12 math, if you've taken grade 12 math already. It's not the same as that. Okay? This means inverse. You read that as f inverse of x. Okay? Fairly straightforward, I think. There's a few questions there for you. This one you have to think about a bit. I know some of you already have worked on that. You're going to have to factor this. Use a y instead of the f of x. Switch it around. Do some algebra. You're going to have to factor something at some point to isolate the y. I'm not quite sure if it's worth talking about this at this particular moment, but I do want you to investigate this a little bit. While we're talking about inverse functions, I don't want to say a whole lot about it here, but if you were to do, I better stop this and start again because otherwise I'll be